look at example 14, which is a word problem set. So real quickly, I'll read it for you. The traffic flow is defined as the rate at which cars pass through an intersection, measured in cars per minute. The traffic flow at a particular intersection is modeled by the function f, defined by f of t equals 82 plus 4 sine of t over 2 for the interval 0 to 30, where f of t is measured in cars per minute. So question number 1, which I accidentally have the answer on here already, my apologies. Question number 1 says to the nearest whole number, how many cars pass through the intersection over a 30-minute period? Well, how would we figure this out? First of all, let's go ahead and look at what's happening up here. So what information is important in my word problem? Well, is my units important? Absolutely, that's important information. Is my function important information? Yes. And is my interval important information? Absolutely. Same units. Okay, so that's the important information we need today. But to answer this question, how many cars pass through that? Well, from 0 to 30, that interval, well, all we're looking for, how many cars are passing through, is what's that area, that net area? Well, what do we know about net area? Isn't that just our definite integral? So we can evaluate that from 0 to 30 of my f of t dt. That says 30, I promise. I go to my calculator, and I have to get rid of the overlay, my apologies. Go to my calculator, I'm going to integrate that definite, evaluate that definite integral from 0 to 30 of So we're going to evaluate the definite integral from 0 to 30 of 82 plus 4 sine of x over 2 dx. And that gives us 247.08. But that's not quite what they asked us. They asked us to round to the nearest whole number. So our answer is just going to be 2,474. But if this were a free response question, could I forget to include my notation on the left-hand side? Especially if this is a free response question, especially if this were a calculator allowed portion, then you may want to include this just in case that's what they're looking for. In case they're looking for, did you know what you were setting up to get that answer? Looking at our next question, this is asking us, is the traffic flow increasing or decreasing at t equals 7? Give a reason for your answer. Well, again, free response questions, they don't just look at one thing. They ask us to kind of look backwards, forwards, left, right, doesn't matter. They're going to pull questions from any aspect of calculus that you've learned about. So increasing, decreasing, that goes back to our f prime and f double prime graphs, doesn't it? We have the graph of f. So how do I figure out if something is increasing or decreasing? Do I look at f prime, or f double prime? Well, if I have a calculator, I can look at f. But mathematically and calculus-wise, I'm actually going to look at f prime. So again, if this were free response, they don't want you to just say, I looked at my calculator. No, they want to know the math behind it. They want to know that you knew to look at increasing, decreasing, you were looking for f prime at 7. And so again, I can manipulate and evaluate. Let's get out of this. Okay, for this one, we're going to use, where's my derivative? There it is. Actually, I don't think that's the right button I wanted. So we're just going to go and manipulate straight from the graph. Okay, what was it? 82 plus 4 sine of x over 2. Okay, and then if we wanted to analyze this, if we wanted to evaluate our derivative at 7, then we actually get that answer, and we see that it's negative 1.87, okay? And so I can see that if we say this is negative 1.8, I don't know, what was it, 7, sure. So what does this tell me? Well, if my derivative is negative at that point, then what does that tell me? Am I increasing or decreasing? Well, we know from ff prime and f double prime days that it is decreasing because this is less than 0. So that would be our justification. It does ask for justification, so here's that justification that I've got. F prime of 7 is equal to negative 1.872. Since f prime of 7 is less than 0, the traffic flow must be decreasing at t equals 7. Okay, our third question is asking, what is the average value of the traffic flow over the time interval from 10 to 15? And indicate units of measure. Well, do we know what average value means? Is that not just that 1 over b minus a times my definite integral? It absolutely is. So here's my b, here's my a. So to set this up, this would be 1 over 15 minus 10 from 10 to 15 of f of t dt. Again, I go to my calculator, I can evaluate that. Let's go ahead and put in that original formula. So 1 over, what was it, 15 minus 10? B minus A. And then times my definite integral from 10 to 15 of 82 plus 4 sine of x over 2 with respect to x. And I get 81.899. So let's go ahead and plug that. So this becomes 81.899. But they don't just want us to finish there, they want us to indicate units of measure. So what would our units of measure actually be? It would be cars per minute, okay? Was that not the unit given above? Was that not what we were modeled? Absolutely it was. So this is our cars per minute, since this is average value. Okay, now we're actually looking at average rate of change. So this is going back to unit 2. We're talking about rate of change. That's that f of b minus f of a all over b minus a. So that's very simple in this instance. We're just going to do, here's our b, here's our a. So we're going to say f of 15 minus f of 10 all over 15 minus 10 is going to equal our rate of change. And so I plug this 15 into my f, I plug this 10 into my f. I do that in the calculator. I'm not going to ask you to sit through and wait for me to deal with that calculator again. And so when I plug that in, I get 1.517. But look at our units of measure. What happened? Well, remember, we're actually thinking, so this is cars per minute divided by, cars per minute divided by, so it becomes cars per minute squared because it is an average rate of change. And those are our 4 final questions for example number 14. That's it for Unit 7.2, the Fundamental Theorem of Calculus Part A. We'll finish up with